Hey guys, welcome back. We are here for lesson 96. This lesson is going to be talking about two main things. We're going to talk about estimating angle measures and distributive property. So we've already talked about both of these things in some respect, so I'm not going to go super in detail, but I do just kind of want to give you a few new tips, and like with distributive, we're going to do a new application for that, okay? So the book actually uses a clock when we're talking about estimating angle measures, because the important thing when you're estimating is that you have to have a point of reference. So you have to have something that you're able to compare what you're looking at to in order to make an educated estimate. Okay, so they like to use a clock, which we could do. I'll kind of show you what they're talking about, and then I'll show you what I think is really the most reasonable way to estimate. But in a clock, they are telling us, okay, everybody knows what a clock looks like, although a lot of you probably just have digital watches now, or you just use your phone. So we don't always look at clocks a whole lot anymore, but you know what one looks like, hopefully. Sorry, my circle's really bad, but you get the idea. So here's all the values on a clock, okay? So if we've got a circle, then we know that a full circle is 360 degrees. Okay, and we know that the 12 values around this clock are each equal distant from each other. So in a standard clock they are. So we could divide the 360 by 12 to see that each one of these distances or angles from one number to the next is actually going to be an angle of 30 degrees, because if the whole thing is 360 and there are 12 of these angles, each one is going to be 30 degrees. So that can kind of help you make some estimations. If you think about the angle that you're looking at in terms of, well, what time would that look like if I were to put it on a clock? Okay, so that's a good helpful tool. I like how they use this. I don't think it is always the most applicable thing. It's great, but here's what I generally use when I'm estimating angles. So when I'm estimating angles, I think about a circle and I think about the four main like landmarks, I guess you could call them. So if we cut our circle into 4 pieces, that makes 4 right angles. Okay, a right angle we know is 90 degrees. So a 90-degree angle is going to look like this. It looks like a big L, right? So then if we put 2 90-degree angles together, that gives us 180 degrees, and that's going to look like a straight line, okay? Then if we put 3 right angles together, that's a total of 270 degrees, okay? And so that's going to look like the outside of an L. Okay, 90 degrees was the inside of an L. 270 is going to be the outside of an L. Okay, and then 360 is the distance around an entire circle. So that's just going to be the whole thing. Okay, so these are good landmarks because you could look at any given angle and say, okay, does that look like it's an L or smaller? And then that can kind of help you make an estimation from there. Or does it look like it's a little bigger than an L, but it's not quite a straight line? So then you would know it's between 90 and 180, okay? So I think this is a really good, it's not as specific as a clock, but again, it's still just estimating. So it just helps you to kind of pinpoint like a good estimation. All right, so if we are given something that looks like this, so if we've got a line with points D, A, and O, okay, and then we have these 2 rays popping out. So we've got this ray, OC, and then this ray over here, OB, and we are asked to estimate the measurement of angle BOC. So we want to track that with our finger, BOC. So we are talking about this angle right here, okay? So now if I kind of turn sideways or this way a little bit and look at it, it almost looks like a 90-degree angle, okay? It almost looks like an L, but it's actually a little bit smaller than an L. So I'm gonna make my estimation based on the fact that I know it's a little bit smaller than an L, but not like terribly smaller than an L. I'm gonna say maybe like 70 degrees for my estimation. So I'm gonna say estimate, this is the little symbol for estimates, 2 squiggly lines. estimate 70 degrees, okay? So then it wants us to use a protractor to measure it. Okay, so I'm gonna try to show you this on here. It may not be super clear, but I'll just review the process for lining up your protractor. So to line up your protractor, you wanna put the little dot. You should have like a little hole or something. You'll see that right there on your protractor. Take that and line it up with the vertex, and then line up the bottom line that comes out of that point with one of the lines of your angle. So like the bottom line of your angle here. Then we're gonna look at where this line goes. So what it touches, we know that it is an acute angle because it's definitely smaller than 90. So we're gonna be looking at the acute value because it always runs through two values. I see it running through an 80 and a 100. So since I know it's an acute angle, it has to be the 80. So my actual measurement for BOC is 80 degrees based on what my protractor said. So the difference was about 10 degrees. That's reasonable, honestly, for an estimate. Especially with angles, it's kind of hard to tell exactly. So when we're estimating, that's a good difference. You want to get as close as you can, but that's still pretty close. All right, let's talk about distributive property. So for distributive property, we've definitely already talked about how to distribute. I know you guys know how to do this, so I'm not even really gonna go over the process. I'm just gonna talk about what it looks like when we throw some distribution into a expression that we have to simplify using order of operations. So let's look at this expression. X squared plus 2x plus 3 times x minus 2, okay? So we want to always start, let's review our order of operations. We've got PEMDAS. Okay, when we are simplifying, we start at the top, work our way down. So we see parentheses here, but there's not anything happening inside the parentheses that we can simplify. We don't know what x minus 2 is, so we are not going to be able to do anything inside the parentheses. However, we do see this 3 directly outside the parentheses. This 3 is squished up against it, meaning there's multiplication happening here. So when there's multiplication happening, we are multiplying it times everything inside. So we're doing this little hippity hoppity thing here where we distribute to everything inside the parentheses, okay? Watch out for this sign here. If this is a negative, you want to make sure you're distributing a -3, but it's positive, so we're good. We just distribute a +3. So let's start with that. So 3 times x would be 3x. 3 times -2 would be -6. Okay, so then I'm just gonna rewrite everything else. Remember, you're wanting to make a nice little ice cream cone here, so we wanna keep writing every single step as we go. Now we look at it and we say, okay, well, I've got an x squared here, I've got a 2x, a 3x, and a 6. The only thing still happening, this is an exponent, but we don't know what x squared is, so we can't really do anything to simplify that, okay? Generally, we would try to do exponents next, but that's as simple as it's gonna get. So then we see, okay, well, we've really only got addition and subtraction happening. Remember, we go left to right with those. So we're gonna see, can we add x squared plus 2x? Those are not like terms, so we are not gonna be able to put those together. So x squared is just gonna stay x squared. We can, however, put together 2x and 3x. Those are like terms because the variable attached is exactly the same in both. So when we put those together, we get a 5x, and then we've got our -6. So what's left is x squared plus 5x minus 6. None of those are like terms. So that is all she wrote. That's your answer. Because you can't simplify anything else there. So if you are done simplifying and you're left with 3 terms, then that's your answer. So always just make sure that you've simplified as far as you possibly can, but that's all that you can do. So that's it. That's estimating angle measures and distributive property. Happy homework.